Hello students, welcome back to another session of maths class. In our last session, we have studied about some concepts of congruency of triangle. In our previous class, we were discussing about exercise 7.3. Now, we will go through the remaining part of the exercise. So students, let us discuss question number 2. What it says? AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. Show that AD bisects BC and AD bisects angle A. Okay. So, let us discuss the solution. Okay. So, students, as per the given data, I have constructed a diagram. So, as per the data, let us consider triangle ABD and ACD. Okay. In triangle ABD and triangle ACD, what we have? We have AB is equal to AC. It is given. Fine. AD is equal to AD. It is common. It is a common side. What else? Angle ADB is equal to angle ADC. Because it is 90 degree. Because AD is the altitude. It is the altitude. That means what we have now? We have two sides and a right angle. Now we can say that it implies triangle ABD is congruent to triangle ACD by RHS rule. Isn't it? We have two sides and a right angle, and we know that RHS says if two sides and a right angle is there, then we can go for the RHS congruency. So, as triangle ABD and triangle ACD are congruent, that means BD is equal to CD. So, which is the first bit? BD is equal to CD. Okay. Why? CPCT. Again, that means it implies AD bisects BC. Proved. The second bit, angle BAD is equal to angle CAD. Angle BAD is equal to angle CAD, again CPCT. That implies AD bisects angle A. Angle A. In this way, we have proved both bit 1 and bit 2 of question number 2. Hope you have understood it. Students, let us now discuss the remaining part of exercise 7.3. Question number 3. It says two sides AB and BC and median AM of one triangle ABC are respectively equal to sides PQ and QR and median PN of triangle PQR. You can see the figure given in your book. I have also drawn the same figure in the whiteboard. So, now we have to show that triangle ABM is congruent to triangle PQN and triangle ABC is congruent to triangle PQR. So, let us go through the solution. Students, M and N are midpoints of BC and QR respectively, because AM and PN are median, isn't it? So, now first, what we have to prove? We have to prove triangle ABM is congruent to triangle PQN, and we know that M is the midpoint of BC. So, as M is the midpoint of BC, we can write that BM is equal to half BC and Qn is equal to half QR. isn't it? Because M and N are midpoints respectively. Fine. Now what else? We have BC is equal to QR is equal to QR, it is given. Fine. And half BC is equal to half QR, that means BM is equal to QN. That implies half BC is equal to half QR. So we have found out half BC is equal to BM. That implies BM is equal to QN, because half QR is your QN, isn't it? Now let us mark this as equation 2. Fine. And now we are going to prove the congruency part. Okay. In triangle ABM and triangle PQN, triangle ABM and triangle PQN, we have AB is equal to PQ, it is given. Okay, AB is equal to PQ, it is given. Again, AM is equal to PN, it is also given. Fine. So we have now two datas which are for the congruency purpose, but we need another data. What else? That is BM is equal to QN, as we have proved it. Isn't it? So we have now three datas for the congruency purpose, so that triangle ABM is congruent to triangle PQN by SSS rule of congruency. Fine. So triangle ABM is congruent to triangle PQN. So we have solved the first bit. Now let us go for the second bit. Okay. Students, from the previous result we have found that angle ABM is equal to angle PQN. Okay. Angle ABM is equal to angle PQN. That implies angle ABC is equal to angle PQR, isn't it? Because angle ABM is equal to angle PQN, that implies angle ABC is equal to angle PQR. Now let us consider triangle ABC and PQR. Okay, here AB is equal to PQ, it is given. Fine. BC is equal to QR. And angle ABC is equal to angle PQN, already proved. Fine. So we have now three datas, and let us find whether they suffice the congruency rule. So we have two sides AB and BC which are equal to PQ and QR respectively, and the angle included angle, that is angle ABC, is equal to angle PQR. That means they satisfy the rule of congruency, side, angle and side. So that's why triangle ABC is congruent to triangle PQR by SAS rule of congruency. So students, in this way we have proved that triangle ABM is congruent to triangle PQN and triangle ABC is congruent to triangle PQR. Hope you have understood this. Students, let us now discuss question number 5. It says, ABC is an isosceles triangle with AB is equal to AC. Draw AP perpendicular to BC so that angle B is equal to angle C. So let me draw the diagram first, then we will discuss the solution. Okay, students, I have drawn the diagram as it is given in your book. You can refer your book or you can see over here. Consider triangle APB and triangle APC. In triangle APB and triangle PC, what we have? We have AB is equal to AC. It is given. Fine. Now AP is equal to PA. It is common. Okay. And angle APB is equal to angle APC. Angle APB is equal to angle APC because they are 90 degree each. Fine. So that's why triangle APB is congruent to triangle APC by RHS rule of congruency. Okay, as these two triangles are congruent, that implies angle B is equal to angle C, CPCT. Fine. So now we have completed exercise 7.3. Let us now discuss some more concepts about the triangles. Okay, students, now we will discuss about inequalities in a triangle. So far we have been mainly studying the equality of sides and angles of a triangle or triangles. Sometimes we do come across unequal objects. We need to compare them. For example, as given in your book, line segment AB is greater in length as compared to line segment CD, and angle A is greater than angle B. Let us now examine whether there is any relation between unequal sides and unequal angles of a triangle. For this, you need to perform the activity that is given in your book. So let me draw the diagram and we will discuss through the diagram, and you can do this activity at your home. Okay? Students, for this activity, you need to fix two pins on a drawing board, say at B and C, and tie a thread to mark a side BC of a triangle. This is a representation through a diagram. In the same way, you have to fix two pins at point B and C and tie a thread such as it will create a line segment, say BC. Fix one end of another thread at C and tie a pencil at the other free end. Mark a point A with the pencil and draw triangle ABC as it is shown in your diagram. Now shift the pencil and mark another point A dash. Now you need to shift the pencil from A to A dash and mark it as A dash. Okay, on CA. So you need to maintain the direction of CA on that line CA. You need to shift the pencil up to point A dash. Okay. Now you can observe that A dash C is greater than AC, isn't it? A dash C is greater than AC. It is quite obvious. Join A dash and B to complete the triangle A dash BC. What can we say about angle A dash BC and angle ABC dash? Compare them. What do you observe? Clearly, angle A dash BC is greater than angle ABC, isn't it? So, you can continue to mark more points on CA extended. We can extend this line up to infinity and we can have multiple points on that particular line. And when we connect those points to B, we will have multiple triangles as well, as we have triangle A-BC. So we can go up to A double dash and we have a triangle A double dash BC. Then also we find that A dash C is greater than AC and angle A dash BC is greater than angle ABC. So from this we can find a pattern, isn't it? Whenever the length of the line increases, the angle at point B also increases. See, initially it was AC, angle ABC. When it goes to A dash and C, as A dash C is greater than AC, angle A dash BC is greater than angle ABC. In the same way, when we have extended it up to A double dash, as A double dash C is greater than AC, angle A double dash BC is greater than angle ABC, and so on. We can go up to infinity. Okay. So students, we have observed that as the length of the side AC increased by taking different points of A, the angle opposite to it, this is AC, angle opposite to AC is B. So when we have increased the length of AC towards A, angle B is also increased. So let us now consider another activity. Okay. In this activity, you need to construct a scalene triangle, that is a triangle in which all sides are of different lengths, and measure the lengths of the sides. You can construct any kind of scalene, just you need to concentrate that the length of each side is different from each other. One of the diagram is given in your book. You need not to follow that particular diagram. You can draw a scalene triangle by yourself. Now just measure the angles. What do you observe? In your triangle, you will find that the angle that is opposite to the largest side of the triangle will be of larger value or will be of largest value. That means if side BC is the largest side of your triangle and if angle A is opposite to angle BC, then angle A will be the greatest angle of that particular triangle. Same way, if AC is the smallest side of your triangle, then the angle B, if it is opposite to side AC, then will be the smallest angle of your triangle. So in that way we arrive at a very important result of inequalities in a triangle. It is stated in the form of a theorem. Let us discuss that. That is your theorem 7.6. If two sides of a triangle are unequal, the angle opposite to the longer side is larger or greater. I repeat, if two sides of a triangle are unequal, the angle opposite to the longer side is larger or greater. We may also prove this theorem by taking a point P on BC such that CA is equal to CP, as it is given in your figure 7.43. You need to draw this triangle ABC and by taking a point P on BC such that CA is equal to CP, we can perform another activity to prove the theorem. Okay. So students, let us perform another activity. Draw a line segment AB with A as center and some radius. Draw an arc and mark different points, say P, Q, R, S, T on it. Okay. So let me draw the diagram first, then we will discuss this activity. Okay. So students, I have drawn the diagram as it is given in your book for the activity. You can also draw the same and perform the activity. Okay. So draw a line segment AB with A as center and some radius. So I have taken the radius as AP. Fine. I have taken the radius as AP and I have drawn an arc and I have some points P, Q, R, S, T. Okay, they are separated from each other and they lie on the same arc. So I have joined these points with point A. Let us now join the points with point B. I have joined point P with B. Let us now continue from Q. Students, you need to do the same with your geometrical instruments on your notebook so that you can understand this better. Okay. Now see, we have triangle APB, AQB, ARB, ASB and ATB with us. Fine. Now, what we observe that when we go from P towards T, okay, when we go from P towards T, the length of AP increases gradually. AP is smaller than AQ, is smaller than AR, is smaller than AS and is smaller than AT, isn't it? So, length of the side opposite to it, which side? The side that is opposite to angle A. The side that is opposite to angle A keeps on increasing. Side opposite to angle A is PB. With the increase of side AP, which is opposite to angle B, the side opposite to angle A is also being increased. PB is smaller than QB, is smaller than RB, is smaller than SB, is smaller than TB, isn't it? So now draw any triangle with all angles unequal to each other. Measure the length of the sides. The side opposite to angle A keeps on increasing with the increase in angle. So you can draw any triangle with all angles unequal to each other. Measure the length of the sides. Observe that the side opposite to the largest angle is the longest. As given in your book, in figure 7.45, angle B is the largest angle and AC is the longest side. You can repeat this activity for some more triangles and you will see that the converse of theorem 7.6 is also true. In this way, we arrive at the following theorem, that is theorem 7.7. In any triangle, the side opposite to the larger or greater angle is longer. This theorem can be proved by the method of contradiction. Now, take a triangle ABC and in it find AB plus BC, BC plus AC and AC plus AB. What do you observe? You will observe that AB plus BC is greater than AC, BC plus AC is greater than AB and AC plus AB is greater than BC. You can repeat this activity with other triangles and with this you can arrive at the following theorem, that is theorem 7.8. The sum of any two sides of a triangle is greater than the third side. I repeat, the sum of any two sides of a triangle is greater than the third side. As it is given in figure 7.46, observe that the side BA of triangle ABC has been produced to a point D such that AD is equal to AC. Can you show that angle BCD is greater than angle BDC and BA plus AC is greater than BC? Have you arrived at the proof of the above theorem? Let us now take some examples based on these results. Okay, so we will discuss example 9. Students, let us discuss example 9. It says D is a point on side BC of triangle ABC such that AD is equal to AC. The figure is given in your book, and I will also draw the figure and we will discuss the solution. And the question demands to show that AB is greater than AD. So let me draw the diagram first, then we will discuss the solution part. Okay? Students, I have drawn the figure as it is given in your book. In triangle DAC, AD is equal to AC. Okay? It is given. Fine. Then angle ADC is equal to angle ACD. That implies angle ADC is equal to angle ACD. Why? Because they are angles opposite to equal sides. Now, angle ADC is an exterior angle for triangle ABD. Angle ADC, it is exterior. Exterior angle to triangle ABD. Okay. So, angle ADC is greater than angle ABD. That implies angle ADC is greater than angle ABD. Or we can say angle ACD is greater than angle ABD, or angle ACD is greater than angle ABD. Or also we can say angle ACB is greater than angle ABC. Angle ACD is greater than angle ABC, because ABD is nothing but ABC. So we can say angle ACD is greater than angle ABC. That implies AB is greater than AC. AB is greater than AC. Why? Because sides opposite to larger angle in triangle ABC. AB is the side opposite to larger angle in triangle ABC. Or I can say AB is greater than AD. Why? AD is equal to AC, because AD is equal to AC. Fine. Now, as per the requirement, we have come to the conclusion of the solution. Hope you have understood this example. So, students, in our next class, we will discuss some more concepts about the triangles. Okay? Till then, keep smiling, take care, thank you.